Welcome to the newsroom. Picture this, all right? You are sitting right there in the examination hall. The clock is ticking down relentlessly, the deadline pressure is mounting in your chest, and you turn the page only to come face to face with a massive, intimidating trigonometric proof. Do you panic, or do you execute a flawless, pre-planned strategy? Today, we are breaking down the story behind the exam question and delivering the headline you desperately need for the answer. We are looking exclusively at the Cambridge Additional Mathematics syllabus, specifically code 0606. I'm your host, your strategist, and I'm going to reveal exactly why mastering trigonometric identities is absolutely 100% essential for your exam success. Here is the undeniable truth. This topic appears in every single examination series. You literally cannot hide from it, and you certainly cannot afford to just wing it on the day. We constantly see two types of students. You've got Alex, who just overloads the paper with raw mathematical facts, but completely lacks the analytical strategy to put them together. And then you've got Sam, who rushes in a panic, misses the command word requirements entirely, and bleeds marks. By the end of this explainer, we are going to transform your approach so you never fall into those traps. You are going to understand exactly what the senior examiners and subject specialists are hunting for when they take out their red pens to grade your paper.
Okay, let's dive right into this masterclass. We have a packed agenda, breaking this down into 5 key areas. We're going to start with the exam identity challenge. Then we'll shift into the core theoretical principles you need. Third, we are taking an exclusive behind-the-scenes look inside the examiner's mind with the top 3 examiner warnings. Fourth, I'm going to reveal the exact procedural framework to tackle these. And finally, we will cover your ultimate exam lifeline, the method mark strategy.
Let's kick things off with Section 1, the Exam Identity Challenge. Listen, the stakes here are incredibly high. As I mentioned, tackling trigonometric identities in the 0606 syllabus is an absolute inevitability. Every single year, thousands of students walk into that exam room armed with raw mathematical facts. They've memorized the textbook, sure, but they are completely lacking the analytical strategy to actually deploy those facts when a complex problem hits them. Our challenge today is to build a solid, unbreakable bridge between simply knowing a formula and proving an identity flawlessly under immense time pressure. It's about moving away from Alex's flawed approach of just dumping facts on a page and moving toward a strategic, methodical execution.
All right, take a look at these. Here are the 3 core identities that form the absolute bedrock of our challenge today. We have sine squared A plus cosine squared A equals 1. Then, secant squared A equals 1 plus tangent squared A. And finally, cosecant squared A equals 1 plus cotangent squared A. Now here's the good news. These are given to you right there in the list of formulas. You don't have to invent them from scratch. But, and this is a massive but, the senior examiner notes a huge pitfall here. Students often struggle terribly with the distinction between the key terminology. They freeze up, completely unsure which formula acts as the master key for the specific lock sitting in front of them. Recognizing the visual pattern of these equations and instantly knowing when to substitute one for another, well, that is exactly where this battle is won or lost.
Moving on to Section 2, core theoretical principles. Now we are transitioning from those raw formulas we just looked at into the actual conceptual framework that underpins them. Because let's be real, the Cambridge syllabus isn't just testing if you can blindly move letters around a page, it is rigorously testing your systematic analysis and your evidence-based reasoning. Cambridge is actively assessing 3 entirely distinct cognitive domains, and you need to hit all of them. First up is knowledge and understanding. Do you actually know what sine, cosine, and tangent represent? Second, application. Can you apply the correct format and use appropriate terminology to manipulate that equation? And third, analysis. Can you evaluate the complex relationships between different trigonometric terms and draw clear, evidence-based conclusions? To truly master this topic, you have got to demonstrate a connected conceptual understanding that is fully transferable to completely unfamiliar contexts. When they throw a curveball question format at you that you've never seen before, your grounding in these 3 cognitive domains is what will save you. Oh, and before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It is literally the best move you can make for your grades.
Now, what's really fascinating about this slide is a specific finding pulled straight from the principal examiner reports. It highlights that the theoretical architecture of these identities rests heavily on integration with other syllabus areas. The examiners explicitly state in black and white that candidates who reference cross-topic connections achieve significantly higher marks. Let that sink in. This means recognizing that trigonometric identities do not exist in a vacuum. They connect seamlessly to calculus, to coordinate geometry, to complex functions. Top-performing students exhibit this incredibly connected understanding, and that's how they scoop up those top-tier marks.
All right, let's get into Section 3, Top 3 Examiner Warnings. I love this part. This is an exclusive, VIP look inside the examiner's mind to see exactly where students are bleeding marks under deadline pressure. These are the red flags that trigger the examiner's red pen.
Let's neutrally walk through these 3 major examiner warnings because they are game changers. Number 1, confusing cause and effect. In a show that question, you absolutely cannot start by assuming the final identity is already true and then work backwards in a circular, confusing loop. You must start from one side and clearly cause the effect on the other. Number 2, forgetting to check format and presentation. Guys, mathematics is a language. If your notation is sloppy or you drop your A's and your thetas mid-calculation just because you're rushing, the examiner cannot and will not award you the mark. Number 3, answers are not specific to the context given. If the question explicitly restricts the domain or asks for a very specific format and you just ignore it, you lose out. Under the immense pressure of a ticking clock, these 3 traps are incredibly easy to fall into.
Let's compare this directly. On the left, we have the flawed approach. Think of our student Alex. Alex overloads the page, completely confusing cause and effect with poor presentation that makes it literally impossible for the examiner to follow the logic. Red pen everywhere. On the right, the strategic approach. Think of a well-prepared student using clear, evidence-based causal relationships. They are using precise definitions and context-specific terminology. They don't just write down the formula. They build a structured, logical argument, much like the Peel framework used in analytical writing. Point, evidence, explanation, link. They state their point, show the formula evidence, explain the algebraic step, and link it to the next phase. The difference between these 2 approaches is literally the difference between a passing grade and a top-tier grade.
Which brings us to Section 4, the procedural framework. How do we ensure we are always taking that strategic approach? We need a bulletproof system. I'm going to introduce the step-by-step technical methodology you need to systematically and safely navigate even the absolute most complex problems. But hey, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, you ready? Here is our brilliant 5-step procedural framework, your mathematics success blueprint. Step 1, deconstruct the question. You have to ask yourself, what is the command word here? Are you proving, solving, or simplifying? Step 2, extract relevant data. Look closely. Which specific trigonometric functions are you actually dealing with? Step 3, select the analytical framework. Look at your list of formulas. Which of those 3 core identities is your master key for this specific lock? Step 4, execute with clear notation. This is where you apply that Peel-like logic. Move through the algebra step by step, providing evidence for your substitutions without dropping your variables. And finally, step 5, present with correct terminology. Ensure your final line matches exactly what was asked in the prompt. By following these 5 steps, you entirely remove the panic and replace it with a cool, professional, systematic process. Let's break down the required skills a bit further. Data interpretation requires you to actively extract information, correctly interpret the hidden relationships between terms like sine and cosecant, and then draw evidence-based conclusions. But that analysis must be rigorously paired with practical application. You must physically apply the correct formats on the page, use appropriate mathematical terminology, and evaluate your own performance as you work down the lines of your proof. The framework demands descriptive, analytical, and evaluative levels of thought. You cannot just guess and hope for the best. You must execute a meticulously planned series of actions to secure maximum marks.
Now we shift to Section 5. Listen to me closely because this is perhaps the most critical part of this entire explainer, the method mark strategy. This right here is your ultimate safety net, your lifeline, for when complex proofs go completely wrong.
So the crucial point is summarized perfectly in this direct alert straight from the examiners themselves. Quote, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. End quote.
I really need you to internalize this concept. Marks are highly awarded for the process itself. When you take the time to select the correct analytical framework and you attempt to execute it with crystal clear notation, the examiner actively wants to reward you. The process is just as critical, if not more so in some cases, than the final answer. Never, ever leave a question blank, and please, never furiously erase your beautifully structured working out just because you couldn't quite reach that final line. Leave it there. Let them give you those method marks.
Getting up to those highest descriptive, analytical, and evaluative levels often requires strict comparative analysis, especially when you're deciding which side of an identity to start proving from. You need to quickly identify the similarities and differences between the left and right sides of the equation. Use comparative connectives in your logical flow. Words like therefore, since, substituting. Support each and every algebraic step with evidence drawn from the 3 core formulas. And finally, draw conclusions about the relative importance of different mathematical pathways. It's a structured argument, not a guessing game. To really help cement this all into your brain for exam day, the subject specialists highly recommend a powerful memory hack. You should create your own mnemonic using the first letters of the key terms from that 5-step procedural framework. Deconstruct, extract, select, execute, present, DESEP, DESEP. Or create a fun one for sin, secant, cosecant. Whatever phrasing sticks in your mind and allows you to instantly retrieve this framework when that exam timer starts counting down. Having that mental shortcut bridges the gap between just knowing the theory and flawlessly applying the strategy under intense pressure. Now listen up. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, AC Exams, at ACExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to ACExams_IGCSE and click that bell. Don't let another exam pass you by.
We have fully deconstructed the identities, we've explored the core principles, we've uncovered the examiner's absolute top warnings, and we've built a bulletproof procedural framework together. So, I leave you with this final provocative thought. Will you apply this 5-step procedural framework to your next past paper practice to secure every possible method mark? Don't just watch this explainer and move on with your day. The real tangible transformation happens when you take these analytical frameworks and aggressively test them against actual exam questions. Drop a comment below right now with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here. Thank you for joining me on the newsroom, and I will see you in the next one.